Hey guys, today we're going to take some notes on Earth's tilt, and then we are going to diagram the seasons so that we can see exactly what our planet looks like in relation to the Earth at each season and why they happen. So first, go to your next clean page in your notebook, and we're going to title it Earth's Tilt, and we're just going to get some basics down about Earth first. So I'm going to draw a circle-ish. This is Earth, so let's get a few details down about it real quick. So these are some basic things that I think we've talked about before, you've probably talked about in different grades. So the first thing we're going to do is we're going to need to divide the Earth into the northern and the southern hemisphere. So I want you to think real quick to yourself, what is that imaginary line that goes around the Earth that we use to divide the Earth in half? It is the equator. So I'm just going to draw a little dashed line, and we know the equator is not a thing on Earth that we can actually see. Humans have made this up. I'm just going to label it equator. So when you think equator, think two equal parts or two equal halves. So whenever we draw a compass for our directions, we know this way's north, south, and then we have east, and we have west. So the top half of our globe is called the northern hemisphere. Northern hemisphere. The northern hemisphere is where we live here in Texas, in North America. And then the opposite of the northern hemisphere is going to be the southern hemisphere. Northern hemisphere, southern hemisphere. Okay. Now, there's another invisible line that we use to describe our Earth processes. So the equator divides us into the northern and southern hemisphere. However, we also have something called an axis. So the axis is opposite of the equator. The equator, we could say, runs east to west. Our axis is going to run north to south. So it's almost like if you took the Earth and you put a skewer in it, like you were going to grill it. The axis starts at the North Pole and ends at the South Pole. So I'm just going to draw these little lines right here. This would be the northern part of my axis, and here's the southern part of my axis. So here's why this is important. The Earth spins on its axis. It rotates. That rotation is what causes us to have day and night. Because the Earth rotates, that also, if you think back to our weather unit, is what allows the sun's energy to evenly warm our atmosphere, and that atmosphere is what helps us have weather. So the axis, if you'll notice, I drew it at an angle. It's not just straight up and down. That's because our Earth is actually tilted. So whenever we are just like this, so this would be straight up and down, but our Earth, or our planet, sits on a tilt. Mars actually does this also. So whenever it's tilted, we need to make sure that we know the degrees, just in case you see it. Our tilt, or we'll say Earth's tilt, is 23.5 degrees. So that is the angle at which our Earth is tilted. Then we're just going to write ourselves a couple notes down here. One, let's zoom in. Earth's rotation on its axis is what enables us to experience day and night. So the half of the Earth that can see the sun or is receiving the sunlight and the sun's energy at one point is experiencing daytime, while the other half of Earth is in darkness. It's facing away from the sun, and they have nighttime. And we know that Earth's rotation takes 24 hours or 1 day to happen. So we can go ahead and add that just for fun. Earth's rotation equals 24 hours or 1 day. Now the tilt also contributes to the Earth having seasons: winter, summer, spring, and fall. What's interesting is because of the tilt, whatever season the northern hemisphere is experiencing, the southern hemisphere is going to be in the opposite season. So for example, right now we are in winter. So if we are experiencing winter, then the southern hemisphere is going to be experiencing summer. So we're going to write that real quick, that the hemispheres experience opposite seasons. We'll write at the same time. And that goes for any season. If we're in fall, southern hemisphere is in spring. If we're in spring, they're experiencing fall. So whatever we are in, or the northern hemisphere is in, they're going to be in the exact opposite. So if you need to catch up on this page real quick, go ahead and pause, because I'm about to move on to our next one. Okay, here's the next thing we're going to draw, which is seasons. And I thought about turning it this way. I think we'll leave it this way because we're going to draw it twice. So right in the middle of our solar system, the thing that gives us all of the energy and sunlight that we need is the sun, the star of our solar system. Literally, it's a star. So here we have the sun. Now I'm not going to draw this to scale. Otherwise the sun would take up the whole page and the Earth would be a little bitty dot outside of our paper. So just for this purpose, this is the size of the sun, and our Earth will honestly probably be the same size. So we have 4 seasons, which means we need to be able to draw 4 different suns. I'm going to start with summer, and I'm just going to show you the way I draw it. If you want to go through a different process, that's fine, as long as you end up with the same diagram. So I'm going to put summer right here. So I'm going to draw the Earth. And actually, I need to be more specific. Summer for the northern hemisphere is where I'm going to start. So here's the sun. We know that the sun is radiating heat and light in all directions. So it's almost like we're drawing little sun rays, but I'm drawing them as arrows just to make sure we remember that the sun gives off energy in all directions. So if this is Earth and I want the northern hemisphere to be in summer, I'm going to need to make sure that the northern hemisphere is tilted toward the sun. That way the sunlight is more directly hitting the northern hemisphere, which is what causes summer. So I am going to signify that I'm tilted this way by drawing my equator and my tilted axis, just like this. So, because the northern hemisphere is tilted directly toward the sun, I know that this is going to be summer. So, for northern hemisphere, this is summer. And if we're in summer, then the southern hemisphere has to be in winter. So, if you didn't know, our Earth's axis, we know that it rotates around the axis, but it actually rotates in a counterclockwise direction. It also revolves around the sun in a counterclockwise direction. So, here is where it is in summer. Eventually, it will rotate or revolve this direction. So I'm going to draw this, but I'm actually going to skip it real quick, because here's the easiest way that I found to do it, is if you do it by opposites. So we started in summer, The opposite of summer, which is going to be on the other side of the sun, is winter. So I'm going to jump over here to winter. Now, summer for the northern hemisphere has to tilt toward the sun, but our axis doesn't ever change directions as it's rotating. So whatever direction our axis is pointing, it's going to keep pointing that direction. So if I bring that over here, that means my axis is still facing the same way. So now the northern hemisphere is tilted away from the sun, which means we're going to be experiencing winter. And remember that they're opposite, so if we are in winter, the southern hemisphere is in summer. Now I'm going to go ahead and draw my fourth season down here. And my arrows to show that I know that the Earth is revolving in a counterclockwise direction. So I personally think it's a lot easier if you start with summer or winter and you fill in the opposite season. Spring and fall is where it kind of gets a little confusing. So the reason I do summer and then winter is because as long as you know what order the seasons happen in, you'll be able to figure out which side is summer and which side is spring. So summer, June, July, August. After summer, June, July, August, we have September, October, November. That's going to be fall, because we know it's summer, fall, winter, and then after winter, December, January, February, we're going to go into March, April, May, which is spring. So again, remember that your axis doesn't change, so if it's tilted on this side, it's going to stay tilted on this side. After summer, we experience fall or autumn. And if we're in fall, the southern hemisphere is in spring. Then same thing, after fall we go to winter. From winter we go to spring. I am going to pause my video here in a second, and I'm going to redraw this, but with the Earth tilted the other way, because it really just depends on what direction from the sun you're looking at. I don't know if that's going to make sense, but basically what I'm saying is that I don't want you to memorize that the summer is always on the right, because it's actually okay if you draw it the opposite, where summer is on the right and winter is on the left. So what I want you to start getting in the practice of doing is actually examining where is the Earth's tilt. So I'm going to draw the second one, and then I will add it to the video, and I want you to draw both in your journal.